Hello everyone, today we are going to be looking at Nmap and network enumeration, and it's going to be covering all these different things over here. You see on the right, enumeration, host discovery, scanning, saving results, service enumeration, the scripting engine, firewall and IPS evasion, and we're going to have some hands-on experience, hands-on fun with this. Okay, so let's quickly read this. So enumeration is the most critical part of all. The art, the difficulty, and the goal are not to gain access to our target computer. Instead, it is identifying all the ways that we could attack a target we must find. It's not just based on the tools we use. They won't do much good if we don't know what to do with the information we get from them. Tools are just tools that we should never replace with our knowledge and our attention to detail. Here, it is much more about actively interacting with the individual services to see what information they provide us and what possibilities they offer us. It is essential to understand how these services work and what syntax they use for effective communication and interaction with the different services. Okay, this phase aims to improve our knowledge and understanding of the technologies, protocols, and how they work, learn to deal with new information, and adapt to our already acquired knowledge. Enumeration is collecting as much information as possible. The more information we have, the easier it will be for us to find vectors of attack. Okay. Imagine the following situation. Our partner is not at home and has misplaced our car keys. We call our partner and ask where the keys are. If we get an answer like in the living room, it is entirely unclear and can take much more time to find them. However, what if our partner tells us something like in the living room on the white shelf next to the TV in the third drawer? As a result, it will be much easier to find them. It's not hard to get access to the target system once we know how to do it. Most of the ways we can get access we can narrow down to the following 2 points: functions and/or resources that allow us to interact with the target and will provide additional information that provides us with even more important information to access our target. When scanning and inspecting, we look exactly for these two possibilities. So functions and resources, or information that provides us with more important information. Most of the information we can get comes from misconfigurations or neglected security for the respective services. Misconfigurations are either the result of ignorance or a wrong security mindset. For example, if the administrator only relies on the firewall, group policy objects, and continuous updates, it's often not enough to secure the network. Enumeration is the key. That's what most people say, and they are right. However, it is too often misunderstood. Most people understand that they haven't tried all the tools to get the information they need. Most of the time, however, it's not the tools we haven't tried, but rather the fact that we don't know how to interact with the service and what's relevant. Sorry, I'm having some tea. That's precisely the reason why so many people stay stuck in one spot and don't get ahead. Had these people invested a couple of hours learning more about the service, how it works, and what it's meant for, they would save a few hours or even days from reaching their goal and get access to the system. Manual enumeration is a critical component. Many scanning tools simplify and accelerate the process. However, these cannot always bypass the security measures of the services. The easiest way to illustrate this is to use the following example. Most scanning tools have a timeout set until they receive a response from the service. If this tool does not respond within a specific time, the service port will be marked as closed, filtered, or unknown. And in the last two cases, we will still be able to work with it. However, if a port is marked as closed and Nmap doesn't show it to us, we will be in a bad situation. The service port may provide us with the opportunity to find a way to access the system. Therefore, this result can take much unnecessary time until we find it. Nmap, or Network Mapper, is an open source network analysis and security tool written in C, C++, Python, and Lua. It's designed to scan networks and identify which hosts are available on the network using raw packets and services and applications, including the name and version where possible. It can also identify the operating system and version of these hosts. Besides other features, Nmap also offers scanning capabilities that can determine if packet filters, firewalls, or intrusion detection systems are configured as needed. So use cases, you can see a bunch of different ones. And Nmap architecture, different scanning techniques, host discovery, port scanning, service enumeration detection, OS detection, scriptable interaction with the target service, syntax. We've already seen a little bit of this in the Metasploit playlist. But yeah, so these are different scan techniques, SSS, TSA, SWSM. So these are different types of scans. We'll go into these. For example, the TCP/SYN scan is one of the default settings, unless we have defined otherwise, and it's also one of the most popular scan methods. This scan method makes it possible to scan several thousand ports per second. TCP scan sends one packet with a SYN flag and therefore never completes a three-way handshake, which results in not establishing a full TCP connection to the scanned port. If our target sends a SYN ACK flagged packet back to the scanned port, Nmap detects that the port is open. If the packet receives an RST flag, it's an indicator the port is closed. If Nmap does not receive a packet back, it will display it as filtered. Depending on the firewall configuration, certain packets may be dropped or ignored by the firewall. Cool. Okay, so here you've got an example. Cool. In this example, you can see we have 4 different TCP ports open. The first column, you see the number of the port. Then in the second column, we see the service status and then what kind of service it is. Cool. Host discovery. Okay, I'm not going to read all of this, but it's always recommended to store every single scan. Okay, the most effective host discovery method is to use ICMP echo requests, which we'll look into. You've got some long command here. This is for finding hosts, right? Okay, this scanner method works only if the firewalls of the hosts allow it. Otherwise, we can use other scanning techniques to find out if the hosts are active or not. Take a closer look at these techniques in firewall and IDS evasion. Scan IP list. Doing an internal penetration test, it's not uncommon for us to be provided with an IP list with the hosts we need to test. Nmap also gives us the option of working with lists and reading the hosts from this list instead of manually defining or typing them in. Easy. If we use the same scanning technique on the predefined list, the command will look like this. Sudo nmap sn oa tnet.il host.list grep4. Okay, cool. As requests, we see that only 3 of the 7 hosts are active. Remember that this may mean that the other hosts ignore the default ICMP echo request because they're firewall configurations. Since Nmap does not receive a response, it marks these hosts as inactive. If you want to scan a small part of the network, you can do that. And just providing the IP addresses there. And you can define a range as well, 18 to 20. And you can scan just a single one as well. And you've got this SN and OA host. So if we disable port scan, Nmap automatically pings scans with ICMP echo requests. Once such a request is sent, we usually expect an ICMP reply if the pinging host is alive. More interesting fact is that our reply scans did not do that because before Nmap could send an ICMP request, it would send an ARP ping, resulting in an ARP reply. Confirm this with the packet trace option. To ensure that ICMP echo request is sent, we also define the option PE for this. Okay. Okay. Another way to determine why nmappers are target marked alive is with the reason option. Host is up, received ARP response. So it's saying before you even get an ICMP reply, you get an ARP ping. Okay. Cool. Used scanning techniques. Does indeed detect whether the host is live or not through the ARP request and ARP reply alone. Disable ARP requests and scan our target with the desired ICMP echo request. We can disable ARP pings by setting the disable ARP ping option. Then we can scan our target again and look at the packets sent and received. Okay, so here we're not doing ARP stuff, we're just doing ICMP. Just a quick aside, if you ICMP, which is Internet Control Message Protocol. Supporting protocol in internet players used by network devices, including routers, to send error messages and operational information indicating success or failure when communicating with another IP address. For example, an error is indicated when a requested service is not available or that a host or router could not be reached. It differs from TCP and UDP. It's not typically used to exchange data, so it's just for error messages, nor is it regularly employed by end-user network applications. Cool. And you can look at the technical details here as well, but that's too far into the weeds, I think. We already mentioned in the learning process at the beginning of the modules, it is essential to pay attention to details, and ICMP echo requests can help us determine if our target is alive and identify a system. More strategies about host discovery can be found here. So I think this is going to take us to the you've got this quite extensive book essentially with all the different commands, and how it all works, and how it all fits together. So we might use this a little bit, read some of the information from here, but I know this is like the full reference guide, so I'm not going to read the whole thing. But yeah, as you can see, it's a big book. It's a long book. So we're just going through this hack the box tutorial, but we'll probably rely on that a little bit as well. Answer the questions below. Based on the last result, find out which operating system it belongs to. The last result. I haven't done anything yet. So what I want us to do here? The information that gives us such an indication is the time to live. There exists a lot of different overviews of different protocols, giving us an overview of which systems work specific TTL values. Are we supposed to do Nmap on this? Maybe we need. I'm not exactly sure. Well, we're going to skip over this because it doesn't look like we can answer that yet. I don't really understand it. Host and port scanning. How the tool we use works, how it performs and processes the different functions. We will only understand the results if we know what they mean and how they are obtained. Therefore, we will take a closer look at and analyze some of the scanning methods after we have found out that our target is live. We want to get a more accurate picture of the system. The information we need includes open ports and its services, service versions, information that the service is provided, and the operating system. 6 different states for a scan port. Open, closed, obviously, yeah, pretty simple. You can read a bit more. It says an RST flag, it was closed. Filtered. Nmap cannot correctly identify whether the scan port is open or closed because either no response is returned from the target for the port or we get an error code. Unfiltered. This state of a port only occurs during the TCP ACK scan and means that the port is accessible, but it cannot be determined whether it's open or closed. And then you get this open pipe filtered. If you do not get a response from a specific port, Nmap will set it to that state. This indicates that a firewall or packet filter may protect the port. You get closed filtered. This state only occurs at the IP ID idle scans and indicates that it is possible to determine if the scanned port is closed or filtered by a firewall. Okay, so discovering open TCP ports, top 1000 TCP ports with the SYN scan SS. The SYN scan is set only to default when you run it as root because of the socket permissions required to create raw TCP packets. Otherwise, the TCP scan ST is performed. This means that if we do not define ports and scanner methods, these parameters are set automatically. Define the ports one by one with this -p, by range, like that, or top ports from the Nmap database that have been signed as most frequent by scan or ports, but also by defining a fast port scan. Cool. So yeah, sudo nmap blah blah top ports equals 10, and it's giving us the top 10 most frequent from the database. Okay, it's also giving us the MAC address as well. Used scanning options. We see that only scanned the top 10, and if we trace the packets, we'll see the RST flag on 21 that our target sends back to us. You disable the ICMP echo requests, DNS resolution, or pin scan. Cool. So that's disabling a bunch of things, and you can see so these are the actual sent and received. Cool. Okay. We can see from the sent line that a TCP packet with a SYN flag was sent to our target. In the next RCVD line, received line, we see the target response to the TCP packet containing the RST and ACK flags are a RST and ACK flags. Okay. Use to acknowledge receipt of the TCP and to end the TCP session. Okay. So that's what that RA means. Time to live, additional TCP header parameters. Additional TCP header. Maybe that was what that time to live thing was talking about. Based on last result, find out which operating system. And it's saying that the information that gives us such an indication is time to live. There exists a lot of different overviews with different protocols giving us an overview. Okay. So how is the time to live 225? How is that helping us? How does that tell us which operating system it is? Which systems work specific TTL values? Interesting. So maybe I should Google ICMP. ICMP time to live 225 and see just what comes up. Values of different operating systems. The time of value, okay. Time to live values are different for different operating systems. You can determine the OS based on the time to live value. That's interesting. Okay. And we have all these different things. So that was an ICMP. So we're looking here. And, well, I mean, there's a whole list of these, isn't there? So it was an ICMP and it was 225. And, do we want to be looking at the sent or the received? Probably want to be looking at the received, don't we? Time to live 128. So if we go down 128, we've got something there. That's TCP and UDP, 128. All these are 128s. These are all Windows. And it's ICMP. So we're looking here, this kind of thing here. We don't know exactly which one, but we just know it's Windows. Cool. Because Linux seems to have a 225. So maybe just type in Windows. Windows, submit, awesome. Okay, trace the packets, filtered packets. We've got down here, haven't we? Yep. Port is filtered. It can have several reasons. Let me drink some more tea. Dropped or rejected. When a packet gets dropped, Nmap received no response from a target, and by default, the retry rate, which is max retries, is set to 1. This means Nmap will resend the request to the target port to determine if the previous packet was not accidentally mishandled. Let us look at an example where the firewall drops the TCP packets we sent for the port scan, and therefore we scan TCP port 139, which was already shown as filtered. To be able to track how our sent packets are handled, we deactivate ICMP echo requests, DNS resolution, and up ping scan. Okay, cool. Okay. So we know the firewall drops the TCP packet here. You're just saying it's filtered. Okay. Nmap sent 2 TCP packets. By the duration of the scan, you can recognize that it took much longer than the previous ones. Where do we get that? Okay. Cool. The case is different if the firewall rejects the packets. So it's not rejecting the packets, it's dropping them. For this, we look at TCP port 445, which is handled accordingly by such a rule of the firewall. Yeah, so it's 0.05 seconds. Okay, that's when you're targeting 445. So when it rejects it, it's pretty quick. When it's dropping it, it's a bit longer. So that's what I got from that. As a response, receiving ICMP reply with type 3 or error code 3 indicates that the desired host is unreachable. And nevertheless, if we know that the host is live, we can strongly assume that the firewall on this port is rejecting the packets. We will have to take a closer look at this port later. Discovering open UDP ports. Forget to filter the UDP ports in addition to TCP ones. Since UDP is a stateless protocol, it does not require a three-way handshake like TCP, we do not receive any acknowledgement. Consequently, the timeout is much longer, making the whole UDP scan SU much slower than the TCP scan. Okay, so we don't get that response back. You can see it takes a lot longer, basically a minute and a half. And that was with the SU. Cool. Another disadvantage of this is that we often do not get a response back because Nmap sends empty datagrams to the scanned UDP ports and we do not receive any response. So we cannot determine if the UDP packet has arrived at all or not. If the UDP port is open, we only get a response if the application is configured to do so. So here, it's actually configured to do so. Okay. And you actually had the reason there. UDP response. Time to live 64. Okay, ICP and pre response to error code 3. We know the port is indeed closed. Okay, closed. Cool. Open filtered. Open filtered. Cool. More information about port scanning techniques we can find there. Find all TCP ports in your target system. Let's do this. Start instance. Let's go. Let's go, boys. Let's go. Spawn all this stuff up. And while that's happening, we have a quick look at this book. So SS was the typical TCP SYN scan, TCP connect scan, UDP scans, init scan, there's an Xmas scan, X scan, Windows scan, main scan, IP scan. A lot of different type of scans. Interesting point is that it's kind of made for privileged users, and it kind of was originally made for Linux, I think. It says a Windows version of Nmap is now available, allowing it to run on even more desktops. For all these reasons, users have less need to run Nmap from limited shared shell accounts. Okay, cool. Anyway, awesome. We've got this full screen. Let's go. We've got the thing here. Find all TCP ports. So let's start bash up. So we want to do Nmap SS. Is that the most appropriate one? SS was a TCP scan. And yeah, TCP SYN scan. Let's do ST. What's the SSST? So you use ST when a user doesn't have raw packet privileges. Okay, well it looks like the SYN scan, the SS is the standard one to go with. And I don't think we need any more details apart from that, apart from the IP address. Do we need anything else? Oh, have we missed out something? Failed to resolve decode supposed IPv4 address S. A? Did we miss something out? No. Sudo nmap. I think you have to maybe put the nmap, the address first, and then SS. No, it doesn't like it. It doesn't like it for some reason. What are we doing wrong? Is that okay? That might be why, because it's supposed to be SS like that. Root privileges, quitting. Okay, well, then we do that. Awesome. You can see you've got the different ports open. Lovely. Lovely, easy. Submit the total number. 1, 2, 3, 4, 5, 6, 7. Enumerate the host name of your target and submit it as the answer. What do you mean enumerate the host name of your target? What does that even mean? How do I do that? Do I have to do some, I don't know, how do I do that? Enumerate the host name of my target. I think we've done that. It doesn't say it here, does it? Is there something we left out? Something we did wrong? How to find host name of target Nmap. One of the most subtle commands of Nmap. Simple DNS query for the specified IP address. It's likely to find host names of all the IPs in a subnet without having to send a package. How to get device name from scan. So if we just do not sure. SN. This gives me the host names along with IP addresses. SN. Is that one here? SN. Okay, let's try SN. That thing said. SN. One IP address up. Doesn't really tell us anything. Is that the same as SN? Oh, we're not sure. No, that's not right. Enumerate the host name of your target. Am I doing something really silly? It's not there, is it? How about SP? Well, it's not giving us the. But just if I just take off all the options. Nice. That's not giving us the giving us the host name. Identify host names. SL. Okay. Tells Nmap to do a simple DNS query for the specified IP. Tells you to find host names for the IPs in the subnet without. Host name information can tell you a lot more about the network than you would think. For instance, if you label your Active Directory servers, you shouldn't be surprised if someone guesses its use. Okay, let's try that. -SL. And it one IP address to 0 hosts up. Okay, this really isn't helping. No idea. No idea. Don't know. Don't know. Don't know. Don't particularly care. Let's go on. Okay. We run various scans, which will always save the results. You can use these later to examine differences between the different scanning methods. Normal output, grippable output, and XML output. Cool. You can also specify the option to results in all formats. Okay. I don't know what OA target thing is there, but whatever. OA target. No full path is given. The results will be stored in directory we are currently in. Next, we'll look at the different formats. And okay, it's given us, yeah. Okay, normal output, grippable output, and XML output. Okay, style sheets. HTML reports are easy to read. From XML to HTML, we can use the XSLT proc. XSLT proc target and HTML. That's cool. That's quite nice. Okay. Let's copy this. Perform a full TCP port scan at your target and create an HTML report. Submit the number of the highest port as the answer. Dun, 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 dun. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, da, da. Da, 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 da. SS. Cool. And let us save it. So let's do what it says here. So we could do the same thing. OA target, or we don't even need OA, we could just do OX target. So let's do that. And then OX target. And hopefully it saved us. So we have target, and now we need to do this thing that's down here, the XML output style sheet. XSLT proc. Let's try and remember it. XSLT proc target dot XML dash O target dot HTML. Cannot pass target dot XML. Why? Am I missing something here? Failed to load external entity. Not sure exactly why that's not happening. Don't know. It's not going to be it, is it? I can't find this target.html. Do we have to put quotation marks around or something stupid? Maybe. No. Do we have to specify that it's like in this directory somehow? That's not going to work, is it? No. I don't know. XSLT proc target.xml. It's not working. Whatever. The highest number of the port we found was 31337. 31337. Awesome. Okay, we're getting our way through this. Service enumeration. For us, it is essential to determine the application and its version as accurately as possible. We can use this information to scan for known vulnerabilities and analyze the source code for that version if we find it. An exact version number allows us to search for the more precise exploit that fits the service and the operating system of our target. Service version detection. It is recommended to perform a quick port scan first, which gives us a small overview of the available ports. This causes significantly less traffic, which is advantageous for us because otherwise we can be discovered and blocked by the security mechanisms. We can deal with these first and run a port scan in the background, which scans all open ports -p-. We can use the version scan to scan the specific ports for services and their versions. Full port scan takes quite a long time. View the scan status, we can press the space bar during the scan, which will cause Nmap to show us the scan status. Cool. Okay. 0 is completed, undergoing SYN stealth scan, blah, 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 blah. Another option that we can use is to find how periods of time the status should be shown. Specify stats every equals 5 seconds or minutes or whatever. Awesome. Also increase the verbosity, which will show us the open ports directly when Nmap detects them. Discovered open port, awesome. Okay, banner grabbing. See all the TCP ports with the corresponding service and the versions that are active on the system. Okay. Cool. Primarily, Nmap looks at the banners of the scan ports and prints them out. If it cannot identify a version through the banners, Nmap attempts to identify them through a signature-based matching system, but this significantly increases the scan's duration. One disadvantage to Nmap's presented results is that the automatic scan can miss some information because sometimes Nmap does not know how to handle it. Let's look at an example of this. Service scan match. Oh, gosh. If you look at the results, you can see that the port status, service name, and host name. NSOC info. Cool handler, read success. Nevertheless, look at this line. Then we see that the SMTP server on our target gave us more information than Nmap showed us, because here we see that it is the Linux distribution Ubuntu. It happens because after a successful three-way handshake, the server often sends a banner for identification. This serves to let the client know which service it is working with. At network level, this happens with a PSH flag in the TCP header. However, it can happen that some services do not immediately provide such information. It's also possible to remove or manipulate the banners from the respective services. If we manually connect to the SMTP server using NC, grab the banner and intercept the network traffic using TCP dump, we can see what Nmap did not show us. TCP dump. Wow, okay. And NC. NC, what's NC again? What is NC? NC Linux, let's type in. It's netcat. Okay. Reading from and writing to network connections using TCP or UDP. It's a backend. Awesome. Backend tool, basically. So we can look into those as well. Okay. TCP intercepted traffic. TCP dump. Okay. First three lines show us the three-way handshake. 59618 to 28, 28 to 59618, 59618 to 28, and you can tell SYN, SYNAC, and ACK. So it doesn't actually say SYN, SYNAC, and ACK, but it does. Well, that one's ACK. Sequence number. Quite a lot of information there. After that, the target SMTP server sends out a TCP packet with the PSH and ACK flags, where PSH states that the target server is sending data to us, with the ACK simultaneously informs us that all required data has been sent. PSH ACK. Okay. Last TCP packet we sent confirms the receipt of the data with an ACK. Okay. Let's copy that. Enumerate all ports and services. One of the services containing the flag that you have to submit. One of the services contains the flag you have to submit as the answer. What? So if we just do this, refresh this, get rid of that. Okay. Whoop. Sudo nmap, nmap. So instead of s, let's do, what was it? -p and dash sv. I think that was basically it. -p dash. And that -p dash, what does that do again? So let's go quickly up here. -p dash, which shows all open ports. So it's a port scan, which is better in terms of detection than a full SS scan. And then the version scan. So version scan. Does it even have it on this one? Doesn't actually show it on this page. Anyway. Yeah. Okay. Let's do that. SV, and let's also do it with the settings thing that it said. Stats every equals 5 seconds. Let's do that, let's be fancy. Stats equals every, what was that, how you do it? Stats every equals 5 seconds. Stats every equals 5 seconds. Let's go. Your port specifications are illegal. Whoops. Okay, so you actually have to give it the ports. Oh, that's specifying a specific port. This, the -p dash, that does all the ports. Something along those lines. A SYN stealth scan. You can see it coming through. About 15% down. So what I think is going on here is that it's scanning for all open ports. So what's the difference between that and just a standard SS TCP SYN scan? So this is TCP scan, and this -p dash. Well, not sure. It's a full port scan. So we can maybe do a quick thing. Nmap, SS, Nmap, SS versus -p dash. Okay. -p dash. See if we can find any more information about this. Nmap -p dash. Make sure that Google's working for us. I don't know why I've got. Oh my gosh, I did not mean to do that at all. Sorry. That. Get rid of that. So this is port specification scan order. -p dash. So you can specify -p dash to scan ports. Okay. So I think just dash p dash is, well, dash p will give a port range, and then dash p dash is all the ports. Okay, so or open ports. Anyway, so you can see here stats, amount of time elapsed, 0 who's completed, 1 up, 1 undergoing service scan. Taking some time, isn't it? About 85% done. Anyway. And you can increase the verbosity level as well. Come on, hurry up. That's a bit stuck, isn't it? Let's move on quickly, just for time's sake. Nmap scripting engine. The Nmap scripting engine is another handy feature of Nmap. It provides us with the possibility to create scripts in Lua for interaction with certain services. There are a total of 14 categories into which these scripts can be divided. Whoa. Malware. Check if some malware infects the target system. Oh gosh, fuzzer. This uses scripts to identify vulnerabilities and unexpected packet handling by sending different fields, which can take much time. Okay. Several ways to define desired scripts. Default scripts with SC. Specific script categories. You just give a category. Define script. You give the script name. First, let's keep working with the target SMT port and see the results we get with two defined scripts. Script banner SMTP commands. And it's given us a bunch of information, which I don't really understand. Okay. We can see that we can recognize the Ubuntu description of Linux by using the banner script. The SMTP command script shows us which commands we can use by interacting with the target SMTP server. In this example, such information may help us find out existing users on the target. Nmap also gives us the ability to scan our target with the aggressive option. This scans the target with multiple options as service detection, OS detection, traceroute, and with the default NSE scripts. That's awesome. Yeah, so you can do an aggressive scan. Port 80. So port 80, stay open. It gives you the service, gives you the version of which service is running. Gives you a whole bunch of different things. Gives you the MAC address, and gives you OS guesses. It gives you guesses. Gives you percentages as well of what it thinks the OS is. It gives you the actual version number as well, which is quite nice. And traceroute as well for the address. Cool. With the help of the used scan option, we found out what kind of web server is running on the system, which web application, I missed that, which web application, there you go, is used, and the title of the web page. You can find the title of the web page? Yeah, wow. Cool. So I'm not really sure what this whole script banner thing was. I mean, it's given us a bunch of different flags, basically. These are different SMTP commands we can use by interacting with the SMTP server. Quick Google for SMTP, just for fun. Simple mail transfer protocol, internet standard communication protocol for electronic mail. Basically, how your emails work. Use level email clients typically use SMTP only for sending messages. Typically submit outgoing email to the mail server on 587 or 465. And for retrieving them, Nmap to replace POP3. So SMTP is for sending messages and Nmap is for receiving them. Again, in the 80s, ARPANET, blah blah blah. Cool. Okay. Are we anywhere service. Hello. Okay. Let's quickly refresh this. Make this bigger. Okay, so it's found us the ports that are open. It's given us the service, given us the version of whatever is the version of the services. Service info. Host Nix Nmap default OS Linux CPE. I've forgotten what CPE stands for. CPE Nmap. Just a quick Google. Common platform enumeration. Standard way to name software applications and hardware platforms. CPE name is a URL that encodes 7 ordered fields. God. A for applications. Okay. Application is kind of hardware and it's an operating system. Okay. It's just some more information basically. Not very interesting. Took us, some time. What was that? 4 minutes? 4 and a bit minutes? Okay, so if we go back quickly, what was the question again? Go all the way down. Enumerate all the ports and services. One of the services contains the flag you have to submit as the answer. Does it? Hey? What do you mean one of the services contains the flag you have to submit as the answer? POP3. What? Well, I'm lost. How does any of that help? How is any of that? Did we definitely do the right IP address? Scroll way up. 180. 180. Yeah, we definitely did the right one. Yep. One of the services contains the flag you have to submit as the answer. Hint. Yeah, I want a hint. I saw information by default. Ooh. Okay, I think we're going to have to do some complicated TCP dump NC stuff. Let's read this bit again. Nmap attempts to identify them through a signature-based matching system, and this significantly increases the scan's duration. So I think this was the problem. Maybe with this one, Elite, where it didn't get the version. So for instance, here. Oh gosh. Good lord. If we manually connect to the SMT server using NC, grab the banner, intercept the network traffic using TCP dump, we could see what Nmap did not show us. So you've done TCP dump, host, and that. Eh? Okay. Well, let's start TCP dump. Good. Good lord. We just pasted this in here, but sudo TCP dump I eth0. I'm going to change that to ton0. Host and. Do we need host and? Can we just do I'm gonna guess, can we just use okay, is this gonna work? Can't pass. Okay, we mucked up. I don't know how TCP dump works. I'm gonna quickly pause and just have a little Google. Okay, I fixed it. Turns out we just forgot the word host, but it's listening on ton 0 for this IP address for that host. Okay, for that host, right? And yeah, the next thing we need to do is this NC thing, NCNV, NC-NV. Should we try it? I think maybe we mucked up. I think maybe we should do. Oh gosh, I don't know. Or maybe we need to do this in a new. Make this bigger. Can we add a new tab? Because I think that's listening. I think if we do it there, it's gonna muck up. File, open tab, new profile, open tab. So we can do nc-nv and the IP address you want. Anything else we need? It's got 25 at the end, port 25. So that was when we. Oh gosh. The problem here is that one of the services contains the flag. So if we go back to here, go back to this one, go back to the port that we think might be of interest, 31337. Maybe that's the one we want. I don't really know. 31337 dash. Go all over the place. So it's. So this is manually connecting. Okay. So nc-nv. Look at nc commands. nc-nv. So that's not going to give us anything. Linux. Netcat utility. And nv, does it have a v? I think must be for verbose. Anything? Don't think there's anything else. The n must be for do not. Oh god. No, that's not really very helpful. 8 practical Linux things. God, you can get really into the weeds with these tools. Whatever, let's just do that, and then you just give a port number at the end. And the port number we wanted to look at was 31337, because it doesn't look like it got a version. So let's try that. 31337. It might not be this port. So it's connected. And are we getting anything from here? Listening. It's listening. Oh, listening on 0. And flag ss dot. Good lord. I don't know exactly what we're looking for. I feel we're close. So I know this. So these flags mean something. So actually, if you just look up, I don't know, network packet flag codes Linux. Maybe that will. This is going to give us. These are TCP flags. These are all the different codes, and it's actually going to give us what the. Doesn't give us the actual. Doesn't give us the codes. Come on. Come on. I saw it beforehand. No, no, it's not. It's not going to give us the codes, is it? It actually was here, wasn't it? Yeah, here we go. This little thing here. SFPR dot. So right here we've got S and then S dot. So you've got S, which is a SYN connection start, and then S dot, which is a SYN ACK. And then we have, well, I'm going all over the place, and a dot, which is acknowledgement. And then we have a P dot, which is a push, data push, acknowledgement, and then an acknowledgement. We have the sequence number, win options. Not sure how useful any of that is. None of it contains what we're looking for. One of the surfaces contains the flag. You have to submit as the answer. So how do we know which surface it is? So banner grabbing. So see, when they did this with disable art ping and packet trace, which gave them all this information here. So maybe we have to go all the way back and do this with those commands. And -n as well, nsock info, nsock trace handler, callback, read success, all that jazz. I don't know how that helps us though. Here we see there is the Linux distribution Ubuntu. I think there might be something I'm missing here. Yeah, I think there's something we're missing here. Well, it looks like, I mean, maybe not, maybe we just have to go through each one. So let's stop this, Control C, 5 packets, okay, and we'll stop. Oh, hello. What was this? We just connected to it. 220, hack the fox. Hey, well, I think that must be it. Well, that's nice. That was similar than I thought it was. Cool. We'll take that as a win, even though I don't fully understand what happened there, but take it as a win. Awesome. Okay, let's quickly do a quick check for time. We are, how far into this shenanigans are we? Oh, 1 hour and 3 minutes. Awesome. I think we could stop there for now, because we have made some progress through Nmap. We're learning little bits here, but the next step will be to use the script engine and its scripts to find the flag. We're learning bits and pieces. It's nice and interactive. It's better than just reading all this. As I said, we will go more into all this stuff here. Is unauthorized port scanning a crime? Port scanning is not a crime. Good lord. Good lord. Good lordy lord. 17-year-old youth was convicted in Finland of attempted computer intrusion for simply port scanning a bank. He was fined to cover the target's investigation expenses. An Israeli judge acquitted Avi Mizrahi in early 2004 for vulnerability scanning the Mossad Secret Service. Oh, dearie me. Even commended other Ians already. Anyway, internet surfers who check the vulnerabilities of websites are acting in the public good if their intentions are not malicious and they do not cause the intelligence, they should be praised. That's hilarious. So I'm in the UK. In 2007 and 2008, broad new cybercrime laws. For example, the UK amendment to the Computer Misuse Act makes it illegal to supply or offer to supply a program believing that it's likely to be used to commit or to assist in the commission of a Computer Misuse Act violation. These laws have already led to some security tool authors to close shop or move their projects to other countries. The problem is that most security tools can be used by both ethical professionals, white hats, to defend their networks, and black hats to attack. These dangerous laws are based on the tool author or user's intent, which is subjective and hard to divine. Yeah, well, you have to have mens rea to commit a crime. You have to have the mental, intention, at least in the UK. So you can always just claim that you're doing it for the public good. You're white hacking, even if you are black hacking. Black hatting. Yeah, I doubt any sort of jury or any sort of court is gonna, never actually pass through the courts, even get to a get to a court, unless you really were trying to, do some crazy hacking. Good lord. It's got some guidelines. Ensure you have permission to scan. Target your scan as tightly as possible. Do not do anything controversial from your work or school connections. That's probably the one that gets most people most trouble. They're like, oh, I'm just going to muck around at work. Probably not a good idea. Nmap offers many options for stealthy scans. IDS evasion, but remember there's always a trade-off. You're harder to find if you launch scans from an open WAP further from your house. 17 decoys or doing subsequent probes to a trade of 9 open proxies. But if anyone does track you down, they will be mightily suspicious of your intentions. Yes. Always have a legitimate reason for performing your scans. Interesting. Can port scanning crash the target computer networks? Yeah, so basically, no application host or network component should ever crash. If they do, that is a bug in the system which should be repaired by the vendor. They do happen. Anyway, we can read some of all this. Cool. It's quite interesting information actually in this guide. What was that I just saw? Mad Hat in Wonderland. Saving the human race, Avatar. God, there's definitely some interesting reading we can dive into. But for now, I think we're going to stop here. We'll continue. We'll pick up in the next video with this NSE and scripts, and then we're going to go down to performance as well, scanning performance and doing some stuff like that. And yeah, then we'll go into firewall detection, IPS evasion, all that jazz, and we'll probably look at some more stuff online about how to use Nmap and find some more interesting use cases and examples. My gosh, there's a lot of stuff here, isn't there? Okay, I'm going to stop there. Hopefully you enjoyed that all. Remember to like and subscribe as always, and I will see you in the next one. Bye bye for now.